Hello everyone, welcome to this first lesson on basic algebra, and I've already been remarking that algebra is really a very powerful tool, and if you're good in algebra you'll probably do very well in higher math. Now for this first lesson I picked up an early article in KVANT magazine, the famous Russian magazine. I think it's around 1970s, and this article, the author deals with solving equations by a good substitution. Now, as you can see that we all know that a good substitution might cause a very nice simplification, and he does so in this article with a series of examples. Now, when I talk about these examples, I shall quickly cut to the chase and talk about the most important idea behind the problem, and I shall also attach the Russian article for you to refer to. So, the first problem deals with an equation like this, and you are supposed to find the value of x. Now, there are four solutions to this equation, and I hope you will actually sit down and complete the solution. But the main idea is, can you come up with a clever substitution to simplify this equation? And maybe if you are doing this for the first time, you might not come up with the following answer. Nevertheless, do take a guess before you look at the answer. So this is a very good substitution in this problem. Now, when you make this substitution, the problem transforms to a much nicer problem, which you can see readily is 1 over z minus 1 over z plus 1 is equal to 1 by 12, and this is definitely very easy to handle. It will just result into a quadratic equation. So with that, I shall stop the discussion on this problem. You can go ahead and complete the solution and compare your answer with the answers in the Russian article that I shall attach in the classroom. Now, let's go to the next problem. The next problem is a very famous kind of trick. So let me write down the equation first. It's a fourth order polynomial, and you are supposed to find all the four roots of this polynomial. Now, as you all know, while we can handle any quadratic equation with ease, you need a little bit of luck once you go to a cubic polynomial or a fourth order polynomial, like in this case. But this is a very specific kind of a polynomial where you see the 4 here is the same as the 4 here, and the 12 here is the same as the 12 here, and this is the middle term which doesn't matter. So basically there is a symmetry here on either side, and the symmetry, because of the symmetry, there is a very clever substitution that will work. So let's try and figure out how to handle this problem. So the first step in this solution to this problem is, let's divide by x square. So let me just divide this by x square. So this becomes 4x square plus 12x minus 47 plus 12 upon x plus 4 upon x square equal to 0. Now the next step is to combine these terms. So the 4x square combines with 4 over x square, and the 12x combines with 12 over x. And let's rewrite this now. So this will become 4 into x square plus 1 over x square plus 12 into x plus 1 over x minus 47 equal to 0. So at this stage, by the way, such equations are called reciprocal equations, and you can see that even order reciprocal equations can be handled in the way that I am writing it down. Now, what is the substitution here? The substitution is, let x plus 1 over x equal to, let's say, z. Now, what to do? Something very nice happens when you square this substitution. We see that z square is equal to x square plus 1 over x square plus 2, and this would mean that x square plus 1 over x square is equal to z square minus 2. So with this, it is very clear what will be the transformation now. This will get replaced with z square minus 2 and this will get replaced by z, and you can see that in this new variable z, it's a quadratic which can be very easily handled. So basically, we were able to solve a fourth order polynomial mainly because of the symmetry. So such equations are called reciprocal equations. Now what happens if reciprocal equations are odd degree? Now for this, let's just write down a fifth degree polynomial in general, and one notices something very nice which causes a simplification. So let me just write down a fifth order polynomial in general. So a x raised to 5 will have a constant term a as a mirror image, and then we can have a b x raised to 4 which will have a mirror image as bx, then c x cube will also have a mirror image cx square, and this is the fifth order polynomial. Now in general, now notice one simple observation: x equal to minus 1 will give us a nice pleasant surprise, will result in the polynomial being p of x will be equal to minus a plus b minus c plus c minus b plus a, and you can see that all the terms gets cancelled and this is equal to 0. What I really meant to write was p of minus 1 equal to 0, and this implies that x plus 1 will always be a factor of odd degree reciprocal polynomial. So with that, let us stop this lesson with whatever we have learned, two good substitutions, and in the next lesson I shall continue to dwell on this article on substitutions. Till then, goodbye.